So I'm going to define the basic p-adic Frobenioid. So definition. Let DP be the category of covers of QP, or spec QP, which are connected in a tall. So these are just field extensions. And then we're going to let FP. Okay, so then here's the definition. The basic p-adic Frobenioid is equal to, well, I'm going to give it the name FP. And this is going to be the Frobenioid. It's the model Frobenioid associated to the following choices. So for an extension K, this is just going to be the order of the monoid. The principal part is just going to be K, the units here, and the divisor map from PK to the groupification here, okay. So this is going to be sending A to the order of A. So let me just kind of say what this is. This thing here is just OK here modulo OK times, and this will be isomorphic to the natural numbers. So let me just do a little example here so we can get used to the notation. So ZP, this is going to be so ZP, this triangle, this is the monoid of units. This thing is going to be defined to be ZP mod ZP times. So these are the units. This is the monoid, so you just remove 0 and you view it under multiplication. But we have that this thing is really p to the n times the units here. So this is really equal to p to the n, or isomorphic to p to the n. This is isomorphic to the natural numbers. Okay, so this is like the basic example. And then we're going to build these Frobenioids out of here, these model Frobenioids. I'm going to say that Mochizuki takes the realification here. Let's see, Mochizuki takes this. So this will be a little bit different. I should also say that this is from the Frobenioids 2, example 1.1. Okay. So this is what the basic Frobenioid is. Oh, let me describe this map. This map here, I should also say that this map here, this comes from taking the natural surjection. The natural surjection here to, which is defined to be K star mod K star. Okay, so the value groups are always going to be multiplicative here. Okay, so the next thing I want to define is I want to define another category. So we're going to define. So these are going to be covers with metrized line bundles. With metrized line bundles. And this is going to be a category over QP here. So the objects of this category are going to be triples K, V, mu. K is going to be cover of QP. V is going to be a one-dimensional vector space over K. And then mu is going to be an element of the realification here. And so let me say what the kind of the value group of vector space. And we define value groups of vector spaces like this. So we take OK times. Okay. So this makes sense. So this is kind of like a projective bundle or projective line kind of. Okay, so now we did the objects, and now we have the morphisms that we need to define. So these things W, let's say new. Okay, this is going to be given by some F, sigma, and D. So D is going to be the degree of the map. F is just going to be a normal map like this. So it's just a cover. Sigma is going to be a map to W, and then we're going to restrict scalars to K. So L sits over K, and so it's going to. This is an L vector space, so we can consider it as a K vector space. And this is going to be such that sigma of, when we take the dth tensor power of this mu, it's going to lie in C times nu K. Let me say a little bit more about this. This is for some C in the order here, the realified order of OK. Okay, so this is again I guess I should mention it, so we get used to it. This is this group, or this monoid, I guess. Okay, and so this thing, I just want to say that multiplication by that in this here, in this makes sense. So, okay, let me go back. Okay, so the lemma that I'm not going to check. So this is on page 8, and it's not stated like as a lemma. This is Frobenioids too. It says that there's an equivalence between Metrized line bundles on QP and FP. And to be safe, I'm going to realify, because Mochizuki does. Okay, so maybe someone will want to say something about this. Okay, I'm just going to move on.